Hello. We're next going to talk about organisms that have endoskeletons. And you're all familiar with endoskeletons because we, as humans, have endoskeletons. That is to say, our skeleton is composed of a series of calcium carbonate bones that are inside rather than outside of our muscular tissue. You can look at our skeleton guy here, and you can see that we have a whole bunch of bones there. How many bones are in the human body, Barry?
206.
206.
206. So we have 206 bones that make us function. I won't ask how many are in the feet, the hands, the heads, because nobody really cares. But that is typical of organisms with endoskeletons. However, there are organisms with endoskeletons that don't actually have calcium carbonate bones. Rather, they have cartilage. So we have here an example of a shark skeleton. Sharks are organisms with perfectly good endoskeletons, but they don't have bone. All of their skeleton is made up of cartilage. And this is an example of that for you so that you know that endoskeletons do not have to be bone. The next item we should probably talk about is the anatomy of a long bone. And to do that, I think I'm going to point at the slide that we have over here that's directly out of your lab manual, in which we have a long bone here. And we've divided it up into sort of three zones. The big head at this end we call an epiphysis. The big end at this end we call an epiphysis. So the epiphysis are the big swollen ends on the end of a long bone. The shaft, what's in between, is called a diaphysis. The center of that shaft may be hollow and contain what is called a marrow cavity. Within that marrow cavity may be bone marrow, which is actually soft tissue that continues to grow and produce blood cells and things like that. At the very top of this epiphysis, we see the picture here has lots of spaces in there. And we call that area spongy bone. Whereas the area on the shaft here in the diaphysis is very dense, and we call that area compact bone. Sometimes you'll have spongy bones inside compact bone, and there's a picture here where they're showing the very outside. You then have 2 or 3 layers of compact bone, and then we have some spongy bone that's growing into the inside here. If we look at a real live bone, as we have over by Dr. Nolt.
This is probably the head of a femur off of a cow bone, so that's why it's so enlarged. In cross-section or longitudinal section here, basically I'm going to do the tapping test here. If you want to see the difference in structure and texture of a spongy bone versus a compact bone, simply tap on it. And if you would have a magnifying glass, you can actually see the spongy nature of this area made up, and this is spongy bone here, okay? Now, if you would tap on the compact bone, here's the difference in sound. That's extremely hard and dense, more light and airy, essentially, in the spongy bone. So this is basically the main difference in anatomy. And we ask you in the lab report, what is the main function? Why is this spongy bone so much lighter and airy compared to the compact bone?
And?
Go, Dr. Williams.
Okay, there we go. Okay. Let's think about this in terms of strength. Which do you think is stronger? Dense compact bone or soft spongy bone? They didn't answer me. Well, I'm going to guess that most of you said, oh, the dense compact bone is stronger. And you would probably be right. But there is a trade-off here in that the more dense something is, the greater amount of energy it takes to bend it or break it, but it is also more brittle, that when it bends, it breaks. whereas soft bone tends to give a little bit. And therefore, part of the function of the soft bone is that it acts a little bit as a shock absorber. As you put pressure on and off that knee, it takes a little bit of that pressure, changes shape a little bit, and then bounces back. And that prevents the long, dense bone from having so much pressure that it actually snaps.
Another reason why we have probably accumulated more spongy bone is essentially spongy bone is lighter bones, and so basically you have to trade off in weight of the organism as well. So we kind of gain a little bit a weight advantage by having more bone, more spongy bone compared to compact bone as well.
Right.
So both of those would be valid reasons why the function of spongy bone.